don't take into consideration. Okay, so by simplifying we will get 1 minus y upon y square into dy is equal to minus of here 1 plus x, so there is 1 plus x upon x square into dx. So we will get 1 upon y square minus y upon y square, that is 1 upon y into dy is equal to minus of into bracket 1 upon x square plus x upon x square, that is 1 upon x into dx. And so we'll get y raised to minus 2 minus 1 upon y into dy is equal to x raised to minus 2 plus 1 upon x into dx. Here the variables are separable, right? Because in the left hand side there is only y terms and in the right hand side there is only x terms. Okay, એટલે કે આ ઇક્વેશનની અંદર ડાબી બાજુમાં બધા y વાળા ટર્મ્સ છે અને જમણી બાજુમાં બધા x વાળા ટર્મ્સ છે, એટલે કે અહીંયા આ ઇક્વેશનની અંદર વેરિયેબલ્સ આર સેપરેબલ. તો આપણે આ ડિફરન્શિયલ ઇક્વેશનના સોલ્યુશન માટે વેરિયેબલ સેપરેબલ મેથડનો યુઝ કરી શકીએ અને એના માટે આપણે બંને સાઈડ ઇન્ટિગ્રેશન કરશું. સો ઇન્ટિગ્રેટિંગ બોથ સાઇડ્સ વી વિલ ગેટ integration of y raised to minus 2 minus 1 upon y into dy is equal to minus of integrating x raised to minus 2 plus 1 upon x into dx. So by integrating we will get minus 1 upon y, and integration of 1 upon y is equal to log y is equal to, there is minus minus plus, so there is 1 upon x minus log x plus c. So after all we will get log x minus log y minus 1 upon x minus 1 upon y is equal to c, and by simplifying I will get log x upon y minus 1 upon x plus 1 upon y is equal to c, which is our required solution. In the same way, if we look at this example here, the question is to find the solution of 4x plus y whole square into dx by dy is equal to 1. And in the same way we can solve this example, because we can note here one thing, that directly this example is not in the variable separable form, but if we take 4x plus y is equal to v, then we can convert this example into variable separable form. If we take here 4x plus y is equal to v, then 4 into dx by dy plus y is equal to dv by dy. And by simplifying, by putting this value in the above equation, we will get dv by dy is equal to 4 plus v square upon v square. And by solving, by simplifying this one, we will get v square upon 4 plus v square into dv is equal to dy. So here now the variables are v and y. So in the left hand side there is a terms involving v, in the right hand side terms involving y. So variable is now separable in this equation. In the starting variables are not separable, but if we change the variable by 4x plus y is equal to v, then we will get v square upon 4 plus v square into dv is equal to dy. In this equation the variables are separable. So integrating both sides we will get here v, by integrating we can easily integrate these terms by v minus 2 times tan inverse v by 2. We know that 1 upon v square plus 2 square here. So the answer is, the integration of this term is 2v minus 2 tan inverse v by 2, and integration of dy is equal to y plus c. So after all we will get, if I put the value of v again, that is 4x plus y. So the solution of this equation is 4x minus 2 tan inverse 4x plus y upon 2 is equal to c, which is the solution of the this equation. So in this way we can solve the differential equation by the method of variable separable. If we look at one more example practically to solve, let us look at one more example. Here the example is solve the differential equation solve the differential equation. 10y into dx plus 10x into sec square y dy is equal to 0. એટલે કે આપણે આ ડિફરન્શિયલ ઇક્વેશનનું સોલ્યુશન કરવું છે. તો આગલા એક્ઝામ્પલની જેમ જ ફર્સ્ટ આપણે એવું ચેક કરશું કે આ ઇક્વેશનની અંદર વેરિયેબલ્સ સેપરેબલ છે કે નહીં. That means we will check that whether the variables are separable in this equation or not. For that, by simplifying this equation, we will get 10y into dx is equal to minus of 10x into sec square y dy, right? So here there is dx, so we need the terms of x in left hand side, and here there is dy, so we need terms of y in the right hand side. So by simplifying, I can write this equation as 1 upon 10x. This 10x comes in the left hand side, so that is 1 upon 10x into dx is equal to minus of sec square y upon 10y dy. Okay, so now you can see that in the left hand side the all terms are of x, and in the right hand side all terms are of y. So here variables are separable. Okay, here variables are separable. So we can solve this differential equation by the method of variable separable. So now we need to integrate this equation both sides. So we will get here by integrating by both sides. By integrating both sides, I will get here there is integration of 1 upon 10x into dx is equal to integration minus of integration of sec square y upon 10y into dy. So here 1 upon 10x, that is cot x dx, and here note that here there is a 10y, and differentiation of 10y is a sec square y is, so 10y is in denominator and sec square y, which is differentiation of this function, is in numerator. So I can write here this is d by dy of 10y, which is sec square y, upon 10y dy. So here I am going to use two formulas. First thing is integration of cot x is equal to log sin x, right? Integration of cot x, that is log sin x, and we know that here integration of f dash y upon f of y into dy is equal to log f of y and plus c. So here something like that. Here the function of y is equal to f of y, that is 10y, and the differentiation of f of y, that is f dash y, that is d by dy of 10y. So we can use this formula to integrate this type of integral. Okay, so after all we will get the integration of cot x, that is log sin x, is equal to minus of log 10y, okay, and plus the integration constant, that is c. So after all I will get log sin x. Here I will get log sin x by integration of cot x, that is log sin x, is equal to minus log mod 10y, that is the integration of sec square y upon 10y, and plus I am putting here constant as log c, okay, for the conveniency. So after all I will get log sin x plus log 10y is equal to log c. Here log a plus log b. So we know that from the logarithms rules, log a plus log b, that is equal to log a into b. So here we will get sin x into 10y is equal to log c. So the final solution is sin x into 10y is equal to c, which is the required solution of that differential equation. So in this way, using the variable separable method, we can solve the differential equation in which the variables are separable. So in this session we have discussed the method of variables or variable separable method. In next session we will discuss the homogeneous differential equation, how to solve the homogeneous differential equation, and how to solve the linear differential equation. So for this session, that's it. Thank you very much.